Welcome to the do-it-yourself exercise covering lesson number 4 and all the reporting important formulas. Try to do the exercises on your own and then check together with me. And we are starting with the formula that is supposed to sum the data for the year and for the month. So this is the scenario for the Sumif or Sumifs formula. But the assumption in here is that we just have the date and we need to have the year and the month. So before we start, it is recommended to create the year and month formula based on the order date that we have in there. So we start with the year, we create also the month, and there are two options to do the months. The first one is just to use the month formula and you will get then the number from 1 until 12, and then you can create an additional data series for your months so that you can connect your initial table with the source table, or you can use the other month formula which will take the text from the date described as 3 letters months, and when you copy this formula down you will get the months in 3 characters shortcut. And now we can start preparing the Sumifs formula, and we would like to sum the sales amounts, but the criteria range is the year should be equal to 2009 and the month should be equal to the month label we have in here. Let's check if that works, and if it does, then it's time for dollars, which means the whole columns will be blocked in here. The 9th, the I column should be blocked, and the 8th row should be blocked as well. And now we can spread the formula to the rest of the table. In the exercise number 2, we are supposed to calculate the number of not available errors, and since we are going to count something, this is the task for the COUNTIF formula. The range is the whole A column, and the criteria, you can apply the NA error in quotes, and you will see that you can find all of the NA errors that appear in A column. In the exercise number 3, we should calculate how many cells equal 1 or -1. So instead of combining all of these conditions into a single COUNTIF, we can just create double COUNTIFs, which means let's check the first criteria for 1, and then we can add another COUNTIF to that based on the same range, but this time equal -1. And when we hit enter, we get 4 cells. What is the sum of sales for products that fall into a range of product IDs between 105 and 110? Because we are supposed to sum the data, we start with sum formula. We have 2 conditions in here, so Sumif would be not enough. We'll take the Sumifs formula. The summing range is the B column, then the first criterion is that A column should be, and now in the quotes, should be greater than or equal to 105. And now we can add another condition on the same column, which is it should be less than or equal to 110. Close the quotes, close the brackets. In the 5th exercise, we need to check if there is only 1 discount applied. So once again, we will count something, and we can start by counting for each of the orders how many X signs we have in there, and you will see that we can have either 1, 2 or 0. And now we can compare that to the expected 1 discount, and we get the true or false value, which is the answer to our question. There is one more formula in Excel that can do exactly the same, and it's called exclusive OR, so XOR, and you can check whether B2 is equal X or C2 is equal X, and you will get exactly the same results. How many true values do we have in exercise number 6? We can calculate that by using the COUNTIF formula based on the A column, and the criteria is just criterion is just true value. And when we hit enter, we get one value, and this is just to remind you that true value in most of the cases equals 1, but not if you refer to it with the true text. When in exercise number 7 we talk about the latest date, from the mathematical point of view, we are talking about the maximum calculation. And there is a brand new calculation in Excel that is called max Ifs formula, where you can select a range of cells, and then similarly to Sumif and COUNTIF, you can add the criteria ranges and the criteria. So in our case, we need the category to be smartphone and the producer to be Samsung. And this is going to be the latest date, but keep in mind to change it to short date. And then we use once again the dollars to block the formula on the third row and on the H column. That is how we can make it appear in all of the cells. When analyzing the data with the exceptions like delivery time, it might be useful to use median formula instead of average. If you don't know this calculation, I can quickly explain that if we have an employee and his delivery times, and if we sort the data, median is like the middle value in this range. In case of a employee, this is in the middle of 3 and 4, so it should be 3.5. And we are talking about this formula because there is no median if formula in Excel, and it's hard to calculate it in a standard way. But what we can do is we can actually calculate the median formula, but based on the data that meet just the condition. So if we assume that the employee in A column should equal E4 cell, in this case we should take his delivery time. If not, let's take an empty cell that will not take part in the median calculation. And if we close the brackets in here and hit enter, we will calculate the median for the employee A. And if we add dollars and copy the formula to the right, we can do exactly the same for the second employee. This exercise is one of these scenarios where picking the whole column is not always the best choice, and in here you can check that this formula slows down Excel a bit. Why is that? Because if we hit evaluate formula, we see that we ask Excel to check all of the million cells in here, whether they are equal A or not. So it is much more convenient for Excel to do in this exercise, instead of full A columns, just the part of the columns that we need. Then the formula will probably work much faster. And what is more, you can also use the table object to do exactly the same. In the next exercise, we will count how many texts we have in this range of cells. And this is the first example where we will use an array formula. So to explain its working better, I will just describe the whole process as simple as I can, and then we will try to create the final formula. So let's start with the first test, which is check whether the value in here is text. And we will get in here the results like false and true. Now the problem in here is that you cannot sum values that are equal to true or false, because you won't get any sum. But if you multiply the result of this formula by 1, you can see that you change the values into 0 and 1, and then you can create also the sum of them. So now when we design the final counting formula, we need to sum at the end all of the results of is text tests that we will multiply by 1. And in Excel 365 you can just hit enter. In Excel before, you should hit Ctrl Shift and enter to apply this as an array formula. The next exercise is once again the example of an array formula, and we have two test results and we need to calculate the difference between them. I will do it in a separate column at the beginning, but then we will try to create exactly the same experience in just one formula, and it's a bit easier than the previous exercise because we can see that we are looking for the maximum of this result difference between tests. So we can take the whole column minus the test number 1 result, and when we hit enter in Excel 365 or Ctrl Shift and enter in the previous Excels, you will see that we just found this number 13. Now a bit more difficult task because we don't have this D column in general, and we would like to use it to like a VLOOKUP information to the left. So the first thing we will start with is the match formula, where the lookup value is the number we just found, and then the lookup array is once again the virtual array that we will create by subtracting data, and the match type is the exact match. Let's have a look what will happen if we hit enter or Ctrl Shift and enter in the previous versions of the Excel. We get the result number 2, which means this is the first row and this is the second row, and we have this number 13 in the second row. So now it's a moment for the index formula, which can take the initial array of names and can give us the row number coming from the match formula, and we get the name of the person who made the greatest improvement. In the next exercise, if we would like to sum the data that we have in A column and we hit enter, because we have some errors in here, the summing operation will also give us an error. How to skip this? How to solve this when you want to avoid taking into consideration the errors? You can once again create a summing formula which will check at the beginning whether the value you have in there is an error or not. So we can check if this is an error, and if yes, then you can just switch, like virtually change from the error to the empty value, and if the value is fine, we can keep the initial value, and then when you sum up this information, the sum will work properly. The second option in here is to use the aggregate formula. That is a very advanced formula that can perform different calculations, and in our case we would like to sum the information, and when we move to the next argument, you can see that there are many internal settings of this formula, and one of them is ignore error values, and then in the last part you just select the range of the data. In the next exercise, we would like to check whether the transaction comes from a promotion or an online campaign, or both of them. So in our case, if we have both yeses, then it's fine. In here it's fine, in here it's fine. This is not the case. So we should get at the end 3 as the end result. And in this scenario, we will use another trick with the logical formulas, which is if we compare one of the cells to a text that we have, we get a value true or false. But if we add to this another logical formula, which is the cell next to it equal yes, then you can see that the logical conditions add together. And the last part is if we check number 2 just and try to check whether the number 2 passes the test, you can see that both number 1 and number 2 can be just a simple condition in the if formula. So to sum it all up, we need some kind of if formula, and then within the logical test we will check whether the whole column of values is equal yes, plus once again the brackets, the other column of values is equal yes, and this will give us 2, 1 or 0. If yes, then calculate as 1, if no, calculate as 0. And we would like to sum all of this information, so don't forget about the sum. At the end we get the desired number 3. To find the number that is occurring most frequently, it's not that hard in Excel, because we have the formula that is called mode, and there is an older version of that, and there is also the mode that will return a single value. So we just select the data, hit enter, and we see that number 1 is the most frequent number in the column. But now the second part of the exercise is a bit more tricky, because we would like to calculate how many sales did the most frequent salesperson make. So we need to first find who was the most frequent salesperson and then calculate how many sales the person did. Let's split this exercise into a bit easier scenario where we will calculate how many sales did the person have. So we would like to check whether in this range the name appears. And if we freeze the cells, we can see that the max of these values is 3. So now if we would like to create just one magic formula that will solve this scenario, we need to do something that will look very strange, which is in the COUNTIF range we can give the names of the people, and also in the criteria we will do exactly the same. And when you hit enter in Excel 365, you can still observe what's happening inside the formula. So at the moment we've just virtually created the column based on which we would like to now find the maximum. So the end of this formula is just to include the max formula at the beginning and hit enter in Excel 365 to find the maximum. In the next exercise we need to include the upper and lower case, and this is the scenario for the exact formula where we need to check whether the Xerox is equal to the cell values, and you will see that we get once again true or false. You cannot sum them, so it's better to multiply them by 1 to get the number that we can just use in the formula. And now if we have this inner part of the final formula, we can just sum all of the information we have in there as the virtual array formula, but instead of just a single argument we can add in here the whole range of cells to calculate the final sum. To calculate the number of unique values, you need to once again use a bit tricky formula, which is 1 divided by COUNTIF based on the range by using the criteria that we are standing next to. And when we freeze this formula and copy it down, you will see that if we have 2 appearances of the same invoice, when we sum up the B column, we will get the final count of the unique values. So now if we have the inner part of this formula, we can try to do the sum at the end using the array formula. So in here we would like to sum up all of the informations, but instead of using just a single cell as a criteria, we can once again add the whole range of cells, And when we close this operation, we will get the final sum as number 4. In the next lesson, we will discover also brand new Excel 365 formulas, and one of them is called unique, which actually removes duplicates from the data we have in a range. So you can see that instead of 5 rows in here, I get just 4. So if we will use something to calculate the number of rows like the rows formula, you can get exactly the same result in a different way in Excel 365. The next scenario is very similar, except for the fact that we need to calculate only the items that occur once. So we can start once again with describing the whole exercise in a simple manner and then to create the final formula. So once again we will use the trick with the count if, but this time we would like to check whether this count, which is in the denominator, in general equals 1, and we will get in here either false or true upon condition we freeze the cells. And you can see that we have 3 times the true value, so if we multiply the whole result by 1, we get the values that we can now use in the calculation. So let's copy the formula and now let's sum everything. And instead of just a single cell, we can select the range of cells and close the sum and add additional brackets to close the formula. The next exercise is more complex and there are many ways to solve it, and I will show you just one of the possible solutions. And we have in here the complaints, and they may appear on the list many times, and we are actually interested only in 2 statuses. The first one open and the second one is the telephone. And to perform this kind of end calculation, we first need to enumerate the complaints statuses we have in the table. And you can do it once again with using a bit of magic with the countif formula. We would like to check how many times in a range from A2 to A2 the value A2 appears. But the trick in here is that once we start copying the formula down, some part of this equation will become fixed. And then when you will have a look how this formula works, it actually enumerates all of the complaint IDs we have in here, because it's like going down with just a part of the formula. So this is like the first part of this exercise, but still we need to join the texts in here. So we will take the complaint ID and connect it with the complaint ID value, and maybe let's add additional minus between them to make sure we don't find not necessary complaints. Now we will use the combination of match and index formula to do VLOOKUP to the left, basing on the complaint ID. So the first lookup we need to make is to find this complaint ID, but please keep in mind that we added additional minus and the number of the status. In our case, we start with the status number 2. We would like to find it in this array, and the match type is 0. And this will become the part of the index formula, but the results should come from the date column, and we have just 1 column, so we don't need to use the last argument. Let's check if that works, and if we get the right dates for the complaints, everything's fine. And now the second part will be very similar, but this time we don't want to find the number 2 status, but number 1, so we can just correct a part of the formula, and we can see how many days did we get between the opening status and the telephone. In the next exercise, we need to find the sum of the 5 largest numbers, and we need to use in here the large formula that allows you to select the array and then select whether you want the first largest value or maybe the second largest value, and from the range. And we could actually create a formula like large number 1 plus large number 2 plus number 3, 4, 5 and so on, but we can do it in a more convenient way just by creating one large formula, and instead of giving in here the single k value, we can create an array that will contain of 5 values, and we would like to sum all of the information in here, so we use one sum formula at the end to create the end result. Now we will look for the invoice ID, but you can see in the payments that this invoice ID might appear many times. So we can use in here the count if formula once again, where we will work on the range that we have in here, but instead of just giving a criteria that is not met in most of the cases, we can supply this criteria with additional asterisks at the beginning and also asterisks at the end. This will make our search more broad and allow us to find how many times does this letter appear in the payment column. In the next exercise, we will create a drop-down list by using data validation and the list option. And as a source table, we would like to add a self-expanding column. And you can do it in many ways in Excel. And the first and the easiest one is just to create a table, because the table is the self-expanding object. And when we go back now to the data validation option, you can see that when you select as the source the whole column of the table, and when you confirm that it should work on this particular cells, you can see the cells available in the drop down. But when you add another cell in here, you can see that the range is self-expanding. So this is the easy way to solve this case. And the hard way by using the formula is the one where you will use a combination of offset formula and defined names to create the same scenario. This will be a bit longer one, so let's start with counting how many items we have in the A column, in the whole A column, because we assume that people will add additional years to the bottom. We have 5, but we need to remove the heading, so I will remove 1 from that, and we can see that we have now 4 years in there, and this particular thing can become a part of the offset formula, where the offset will start at the A2 cell, and then we will not go down by any rows, we will not go to the right to any other columns, but we would like to increase the height of the range from one cell to the number of cells we have in here. And when we hit OK, you will see that Excel 365 is showing me the current range, and when we will increase the number of things, the formula in Excel 365 expands. This kind of formula is not possible to be included already in the data validation, but you can create first the defined name that we will call for example range, that will include the whole offset formula. You need to keep in mind the dollars are quite important in this case, and then you can check whether your formula works by going to the named value range, and you can see we selected exactly the range we are looking for, and now I can apply the same to the data validation, where as a source I will include my range value. And now you can see that the drop down works, and when we add new elements, the offset formula below hidden in the defined name expands, and we can also see the expanded drop down. Another trick with drop-down list is that when you select something from the first level drop-down list, you will limit the number of things you can find on the second level drop-down list. To be precise, we can start with creating the first data validation, which will be once again the list where you can select the category. And this is the first drop down when you can choose between the producers. But now when we select the Apple, we would like to see just the models of this manufacturer. How to do it? First, you need to create new named ranges that will have exactly the same name as the category name. So I call this product Apple, and the second one will be called Samsung. Now you need to create a defined name that will use the indirect formula to redirect you to the proper ranges. So I will call it just the name and use the indirect formula that will come from the G1 cell. You can check now what is the name result, because when we are in Excel 365, we can apply it as a spilled RR formula and we can see that it works. So now it's the last step. We need to create the data validation rule, and instead of giving the cells, we will give the defined name, and we can check that it works now and shows us the proper products from the second level dropdown. And in the last exercise, we will create a defined name that will span all over the table. And if we add a new heading or a new row in the product ID, the table should expand on its own. And this is once again a scenario where we'll just create the defined name, and you can find on the internet many applications of this kind of defined names. So let's start with counting how many cells do we have in the first row, and we have there 6 cells. So now let's check how many rows do we have in the table, including the heading, and we have 12 of them. We need to be careful with the task in here to avoid placing the task in the first row, as this is the counting element. And now we can once again use the offset formula and start with the A1 cell, and then not go down rows and not go to the right with the columns, but use the parts of the formula width and height that we have already created. And when we paste them in the proper arguments height and width, you will see that we refer now to the whole table, and when we create a new heading, the new heading will appear, and when we create a new row will also appear in this range. So now you can use this range in very advanced scenarios, and it will always grow with your data. And to complete the task, we will copy the formula and create a defined name out of it, and we'll call it the solution. And this is the final solution that we can find in here. Once you hit F5 to check the solution, you will always go to the desired range.